Hello and welcome to Straight Line Graphs. Let's get straight into this. First of all, what you must know is that the general equation of a straight line is written as y equals mx plus c, where m represents the gradient of the line, which is how steep it is, and we will talk about that in more detail. And the c is the y-intercept. The y-intercept just means where the line crosses the y-axis. So, for example, if your graph looked something like the following. And this was your line, that would be the y-intercept, just where the line crosses the y-axis. So what we have here as y equals mx plus c is the general equation of a straight line. So you would have a number where the m is, and a number where the c is. For example, y equals 2x plus 1 would be a particular line on a graph which has a gradient 2 and a y-intercept of 1. So let's focus on gradients now. The line with a positive gradient would be sloping in this direction. So any of these lines would have positive gradients because they are effectively sloping upwards from left to right. A negative gradient would therefore be the opposite. It would be going downwards from left to right, like that, or like that. Now, you also just need to be aware in some questions that you have to draw straight lines. And let's say I asked you to draw the line y equals 2x plus 1, the example that we just did earlier. Then there's a couple of ways to do this. Now, the easiest thing to do is to draw a small table of x and y values, because what we have here, when I say y equals 2x plus 1, it is a little formula that tells you what the y coordinate is whenever I put in an x coordinate. So for example, if I choose a couple of x coordinates like 0, 1 and 2, it's easiest just to choose a few easy small ones and substitute each of these into where the x is. Remember, that means 2 times x. So when x is 0, I would have 2 times 0, which is 0, plus the 1, which would give me that y is 1. If you do the same when x is 1, you would get 2 times 1 is 2, plus the other 1 would give you 3. If you did the same with the 2, you would get 5. And what these become are some coordinates that you can use to plot a graph. So if we just take a couple of straightforward ones, 0, 1, let's say, is there. 1, 3 would be there, and then the 2, 5 would be further up. But that would give you a line that looks like that when you join up your points. So that is a nice simple way for you to draw a straight line. Now, sometimes you are given some information and you have to find the equation of the straight line. So, for example, I might ask you the following question. Find the equation of a line which passes through 0, 7. So I'll give you a point that it passes through. And has a gradient of 3. Now, I have told you the gradient of the line. It is 3. I have also told you that it goes through 0, 7. Now, whenever I tell you the x-coordinate is 0, and I tell you the corresponding y-coordinate, this must be the y-intercept. In other words, the 7 is the y-intercept. Only because I've told you the x-coordinate 0, therefore the y-coordinate is the y-intercept. It is where the line will be crossing the y-axis, because on the y-axis the x-coordinate is 0. So now that I have the gradient and the y-intercept, I can use the fact that I know that the general equation of a line is y equals mx plus c, where m is the gradient, so I can sub in 3 where the m is, and the c is the y-intercept, which I know is 7. That gives me a nice, easy answer for the equation of this line. Now, let's do a different one. If I take this and just change the numbers slightly, so this time I'm going to tell you that the line passes through a different point, 2, 3. And I want to tell you it has a gradient of 2. So this time, whilst this is the gradient, of course, because it tells you it is the gradient, I don't have the y-intercept, because this doesn't tell me the y-intercept straight away, because the x-coordinate is not 0. So what I can do is still first write down that because I'm finding the equation of a line, I am going to use y equals mx plus c. I know what the m is because I've been told that the gradient is 2. I still don't know what the c is though. And this is where we use this point, the 2, 3. So what I'm going to do is sub in 2, 3. Now remember, when I say 2, 3, the 2 is an x-coordinate and the 3 is a y-coordinate. So in this equation, I am going to replace the y with 3 and replace the x with 2, because it tells you that x is 2 in here. So 2x would be 2 times 2, which is 4. Now I have a little equation that allows me to work out what the c is. I can move the 4 to the other side by taking it away, and I've worked out that c is -1. So my final equation is y equals 2x, because I knew that the gradient was 2, minus 1, because I've just worked out that the c, or the y-intercept, is -1. We can now move on to actually working out the gradient. In the questions that we've just seen, the gradient was given to you in the question. It was quite straightforward. You didn't have to do any work to find it. Now we will be finding the gradient from 2 points. So I'm going to give you 2 points on a line. For example, I'll give you 3, 4 and 9, 7. So imagine a line that goes through these 2 points, 3, 4 and 9, 7. Now let's show roughly what that would look like on a graph. Just a very, very rough sketch. I won't use the squares on this paper, but I will show you that let's say that that is 3 and this is 9, and let's just say that this is 4 and up here we have 7. Okay, so the line goes through 3, 4 and 9, 7. So it looks a little bit like this. Okay, and it goes on further. Now we will continue it further. Now the fact that I have 2 points on this line allows me to do something like this. I can make a little triangle using the 2 points that I have just found, and I can work out that the length over here is 6 because it goes from 3 to 9. And the length over here is 3 because it goes from 4 to 7. Make sure you look at the coordinates that you are given, not just the squares on the paper, because the scale might be different. Now, to work out the gradient of a line in this situation, you basically just do how far up you've gone divided by how far across you've gone. Or you can think of it as the change in the y-coordinates divided by the change in the x-coordinates. In this case, my y-coordinates have changed by 3. My x-coordinates changed by 6. And that gave me 3 over 6, which can simplify to a half. The gradient of that line would be a half. because of what I have just shown you here. Now, you could think of this slightly differently. You could just write down the coordinates and not draw the triangle and the line, so 3, 4, and 9, 7. And you could just look at the y coordinates and say, how did I get from here to here? I added 3. And how did I get from here to here? I added 6. So my x coordinates involved adding 6, my y coordinates involved adding 3. You do the change in the y coordinates, which is up, divided by the change in the x coordinates, which is across, and you will again get the same thing, 3 over 6, which becomes a half. So that's basically how we can do this. As long as we know any two coordinates on a line, we can find the gradients. Okay, so we'll just make a note of that. So we'll just do one other example of that. If I gave you these coordinates 3, 7, and 5, 15, you can say, okay, well, how much did the y coordinates change by? To get from 7 to 15, I add 8. And how much did the x coordinates change by? To get from 3 to 5, I add 2. My y coordinates have changed by 8, my x coordinates by 2, and so 4 becomes the gradient of that line. Now, we can put the two things that we've learnt here together. If I just gave you two coordinates, okay, so if I gave you these two coordinates, 3, 7, and 5, 15, and I asked you what is the equation of this line, so the one that goes through those 2 points. Well, I know that the equation of a line looks like y equals mx plus c. I have just shown you how you work out the m. The m is the gradient, and we saw that that was 4 in that same method. So I know that 4 is the m. I can now find the c by subbing in one of the points that the line goes through. Okay, so we're going to sub in a point . For example, 3, 7. It doesn't matter which one you choose. So I know that according to that coordinate, when y is 7 on this line, so I'll replace the y with 7, the x is 3. So 4 times 3 is 12. So I can now work out the c by moving the 12 and doing 7 take away 12. I'll get negative 5 for c. So my final equation becomes y equals 4x minus 5, because I worked out that the gradient was 4, and I've just worked out that the y-intercept is negative 5. So that becomes the full equation of that line. Now let's put all of this together in another example. So I'll show you another question. And here it is. So find the equation of the line which passes through 5, 4, and 6, 7. So we're given two coordinates. We have to find the equation of this line. First thing I'm going to do, because I want to find the equation of a line, I'm going to write down the general equation of a line, y equals mx plus c, which tells me that I just need to work out this number and this number, the m and the c. We will work out the m first, okay? And the way you work out the m is you write down your 2 points, and you work out the change in the y coordinates. So my y coordinates have changed by 3 here, and my x coordinates have changed by 1. And then you do the change in the y coordinates, which is 3, divided by the change in the x coordinates, which is just 1. And so my gradient is 3. I have worked out my gradient. So I can write down y equals 3x plus c. I will now find the c by subbing in one of the coordinates. So I'll just choose the 5, 4. So when y is 4, x is 5, so 3 times 5 is 15. Therefore, to get the c, I'll move the 15 to the other side by taking it away. 4 take away 15 is negative 11. And so my c is minus 11. My final equation is therefore y equals 3x minus 11. Right, we will now talk about midpoints. You often are asked to find the midpoint of a line. So imagine a line passes through these 2 points, 3, 4 and 5, 8, and you have to find the midpoint of the line. So let's imagine that 3, 4 is around here and 5, 8 is over here somewhere. You are being asked to find the midpoint, so exactly the point that's in the middle of those two. And it's really quite simple. All we need to do is add together the x coordinates and divide by 2. So the x coordinates are 3 and 5. Which is 8, and then 8 divided by 2 is 4. That becomes the x coordinate of your midpoint, and then do the same with the y coordinate. So add so the y coordinates in this case were 4 and 8. 4 and 8 makes 12. 12 divided by 2 is 6. So my midpoint is at 4, 6. That is the midpoint. Lastly on this topic, we will just talk about parallel lines and what the word parallel means. So parallel lines have the same gradient. In other words, they are going in the same direction. So for example, these two lines are parallel because they are going in the same direction. They have the same gradient. So you can get asked a question like this. What is the equation of the line which is parallel to y equals 2x minus 1 and passes through 1, 8? Now, if it's parallel, the line that we want is parallel to y equals 2x minus 1, it must have the same gradient. So if this other line has a gradient of 2, then our line must have a gradient of 2. So we can begin to write our answer as y equals 2x plus c. The gradient must be the same. The only thing that's different in our line is that the y-intercept will be different. And now that we've got to here, because we know the line passes through 1, 8, we can sub in 1 and 8 into this and find out what the other c is. So when y is 8, x is 1, so 2 times 1 is 2. So to get the c, I'll do 8 take away 2, and I will get c is 6. So my new equation is y equals 2x plus 6, rather than the other one was y equals 2x minus 1. So they're parallel, they have the same gradient, but they would have a different y-intercept. Now the last part of this topic involves rearranging equations. So sometimes you might be asked for the gradient of a line which doesn't look like y equals mx plus c. Now the important thing to remember is we need the equation to look like this in order to find things like the gradient and the y-intercept. So if you, for example, had this as your equation and they asked you for the gradient, what you would need to do is rearrange this so it looks like y equals mx plus c. So we would move the 2x to the other side where it becomes a minus 2x. The 3 is still there. And then we can see that this is the gradient. And that is, of course, the y-intercept. So it just goes to show that just because you've got a line that looks a little bit like y equals mx plus c, that doesn't necessarily mean that that's the gradient. You would have to rearrange it to make it look like that first, and then you would get that. Another example would be something like if I give you 2y minus x equals 6, I would need to rearrange this first to make it look like y equals mx plus c. So I would add the x to the other side, then I would divide by 2, so I get the y on its own. 6 divided by 2 is 3. So I can see now that that is my gradient, and that is the y-intercept, which you couldn't tell when we first looked at this line. So we needed to rearrange it to make it look like y equals mx plus c. Then we were able to find the gradient and the y-intercept of the line.